Hello, everybody. So, the plan for tonight has more examples, mostly kind of picking up with those. I don't know if you've looked ahead at the next couple projects. The next one is a card game, and then there's like a Scrabble game, which sort of a word game. And then we get into a more player movement, sort of knockoff of the original Legend of Zelda, or at least part of it. And I was thinking that when I was putting the plan together for the class, I was thinking, well, there's the card games and stuff, then our class lectures can do a lot of the examples of movement and things. Because obviously when I show those in class, I can go over the way I do it, which might be different than the way the book does it. And I was thinking if there's both of them at the same time, right? You sit through the class lecture and then go work on the weekly assignment right after class or something. It might be confusing seeing multiple ways. I think everybody's aware of that, right? In programming, we have more than one way to do things. There's similarities, and when you take a step back and examine what the code's doing, you can usually see what the multiple methods have in common. But when there's a lot of information coming all at once, that can be a little confusing. So it seems like my plan for that is kind of falling into place, where we're talking about movement and stuff, player movement the other day, and enemy opponent movement this evening, while the game is about a card game thing. And I have a couple tips for card games, because likewise, I do things different for card games as well. We can look at next Monday or something, because you're probably going to want to follow along that tutorial, because there's a lot of other things in there. Like, they build a card. They use a whole bunch of different pieces to assemble the image of the card as needed, instead of just having a bunch of images of cards. That's what I've always done, because there's a bridge club that has some really nice cards, and they put a nice naming convention on them. So I've been using their cards for years, which is just an image of a card. And there's a couple other Unity tricks worked into the prototype this week for putting those together, which will be very beneficial when you get to like animations and stuff. And you have more complicated character images that you need doing things. The core idea of it is assembled there with cards this week. And while your all's weekly project is about cards, we'll talk about movement in class. What else do I have in here? A couple people who have had me before in class, I noticed, remember doing this before. If you have questions about stuff, like it shows up sometimes in programming, things work and we don't really understand why they work. Like, you get your code works, and so you don't want to take a bunch of time to stop by my office hours and ask questions or something about when the code's working, but you might not fully see what it is. So if you have some things you're curious about, or would like more clarification and things, you can put questions in the comments, and I will try to address them when I add the comments back in the grade book about that. So that's a good place for comments. My to-do list says website generator. Oh, I remember. Which one was it? I don't think I have an example of it. I have to pull it up from the textbook. Let me share my screen real quick and jump into the textbook. Unless somebody has the script for that last game convenient, where you could share your screen. The bounds check script is the one.
I do.
Oh, if you can share your
sorry,
screen.
I didn't have my thing muted.
I'm still like 5 or 6 clicks and a password or two away from the textbook going in that way. I meant to grab one and forgot to do it before class. And yeah, I can't even remember what the to-do list.
What happened here? Oh, I think you had to stop sharing for me to do that.
Oh, I thought I stopped. Okay, I stopped sharing. Is it not
letting you see my screen or no?
No, I do not. No, I do.
Okay.
So on the bounds check up at the very top, they put some stuff in at the very top. Oh, you didn't put it in yours. The book had a couple other lines there. Well, we can talk about what they look like. If you right underneath that, there was some comments that had 3 slashes. And then some
Oh,
HTML code.
yeah, I chose not to do that.
Yeah, that was, yes, that. And how it automatically generated as soon as you did the 3 slashes.
Well, that was probably the IDE.
Yes, that's what I was going to point out. So I think our textbook uses that some. I'm drawing a blank on the name. I never used that one, but that's the automatic website generator, the preferred one Microsoft uses, so that our comments do something. Y'all may have had other instructors going over programming stuff that made a big deal about comments, and I tend not to. Usually we look at website generators, if anything, because if we want to document our code, it's a lot easier to read that stuff on the website. So that thing right there that the textbook does, that relates to Microsoft's preferred website generator. And those are the kind of comments that I usually pay attention to, the things that because, well, all a comment is in the case of C#, the compiler ignores that text and looks at the code. So there's nothing that stops us from ignoring the C# and looking only at the comments. So we can do other stuff if you haven't worked with that before. Okay, thank you for sharing, Andrew. I was.
What was the so what is you were saying something, it's a website generator? What is that? I missed the very beginning of class. I apologize.
Oh, okay. That line, those lines just relate to a website generator. I was going to say, if the textbook mentions them, you don't necessarily have to include those. So a common one the one I use most often would be Doxygen. I think I have something on my GitHub right now.
Is it a document generator? Is that what you're talking about?
Yeah.
Oh, okay.
Yeah. So this one has the comments. Well, actually, I can use that, can't I? I think it's in here. So in this thing, there's just, I use Doxygen, so the comments start with an extra symbol like this. And then there's some keywords we put in the comments. And from that, nope, it's not going to let me open that thing. Do I have it locally? I don't think I have it locally. This hopefully won't take too long. There's not much in that file. And then from those comments, we get an entire website of documentation like this.
Oh, that's super cool. And it's called Doxygen, you said?
This is Doxygen. That's my favorite one. It was originally for C++, but they've extended it to other languages.
Yeah, that's pretty sick.
Yeah. Okay. Yes, that's the comments I usually show. We will look at some. That summary one is Microsoft's preferred, the one Microsoft prefers. I can't remember what the official name of it is. Microsoft official documentation generator. Oh, maybe it's just Microsoft Docs. Yeah, but we put special symbols in our thing. So like when we look up something in C#, random numbers in C#, it generates a website with this style page. Oh, that's not the one I wanted. And look at the official documentation, which I guess now might be a good time to remind you all of this. Always look at official documentation first. Obviously, official documentation is often kind of cryptic and hard to follow because the people that are really good at writing code might not be so good at writing English sentences describing that code. But always look at official documentation first because it stays up to date. Official documentation is always going to be up to date, whereas tutorials can get out of date with our languages changing and things. So those comments, the 3 slashes intermingled with HTML, that generates a website with this style sheet. Yes, what's that, Andrew?
So I had ran across not too long ago, and I want to kick myself for not saving it, but there was a website that, you could type in, the language you knew, and then it would generate to the language you wanted to know about. So if I want to know how to write function in from a language I knew into the language I don't know how to write, it would show me how to do that. Are you familiar with any websites that do that?
There are a number of things that can do that. Are you familiar with Blockly? Most people encounter this with Scratch. It's actually a plugin Google made, the puzzle piece things. If you put it together that way, you can generate code in any language that Google knows. So you can use a tool from that plugin to translate any language into another one. Have you had your SDEV 264 class?
Which one's that? Is that
website development?
Yeah, I think so.
Usually it's taught using Java, Android Studio with Java and making mobile apps.
Oh, yeah.
So the thing is, Android runs Kotlin, but nobody knows Kotlin. So most people use Java or C++ or any other one of the more common languages. And before it compiles, a translator automatically turns it into Kotlin. So there are lots and lots of those. And you could probably make your own. Obviously you described it in a learning situation, so you wouldn't know the other language, but if you knew, when you know 2 languages, like say Python and C#, it's just parsing a text file. You read through a C# script and replace, and when you see the keywords that show you have a function, replace that with DEF. And when you hit the curly braces, replace the curly braces with the colon and then indent until you hit the other curly brace. So translating between languages is just a matter of parsing the text file. I don't know of any off the top of my head, but I could try to help you narrow down some that are good. Or just have to search for it.
It's okay. We don't have to do it now. I was curious if you knew something off the top of your head.
Not off the top of my head, but it really is just a matter of parsing the text file. So it's a very easy thing to do, and there are lots of them out there.
Cool, thanks.
And yeah, and Google has several. There's with the Blockly, it's a whole plugin. So one of the classes in there will do it, but not in like an education setting, not like you were mentioning, not to learn another language. It would just, you'd write your code and it would just spit out the other language. Because yeah, it has to do that for the puzzle pieces, has to turn it into text. It's one of those types of low code solutions. But I know there is a file in there that will do that if you just wanted to have something that would do it without having to write it yourself. But yeah, usually with comments, I prefer comments that do something, because there's nothing that stops us from going the other way and ignoring the C# code and only looking at the comments. So we can do 2 things in one file. And website generators are, it's much easier to read our documentation and the comments about the stuff on a website instead of looking at the code. And yeah, if you missed the beginning, Andrew, I think one of the first comments I made was, if you have questions and maybe the code works and you would like a little more clarity or something, you can put the questions in the comments, and I will try to write something up whenever I do the comments on the grade while grading. So that was 2 things I had about comments. Yeah, and then, well, our project this week is a card game. So to hopefully avoid confusion, I was wanting to talk about movement and stuff the way I'm used to doing movement, my style, which is a little bit different than our textbook author style. I was thinking if I talk about that while our weekly game isn't doing a lot of movement, then there's some, it hopefully be less confusing, and we can just pay attention to the concepts, not the, or you'll have some variety next time our games get back to movement and stuff. But there are some useful things in there, like they build the cards from small images. So they have a program script that builds the cards, which can be very useful when we get back to more complicated situations where things are moving and stuff, and we can kind of program the images if they're built up. If we just have a single image, it's kind of hard to do something with that programmatically. But when what appears like a single image on the running game is actually a whole bunch of different images, we have a lot of control over what we can do with that in programming. So I was going to jump into some more stuff with movement this evening, and I guess we looked at one way of moving the player the other day using the nav mesh, which I forgot a couple points right off the bat, but that works for our opponent players as well. So I was thinking we could start there, and then we'll do the controlled movement, like what we would, the equivalent of the user pushing the keys, to kind of see what's similar between them. One thing I noticed is y'all had some great ideas with this week's discussion board game theory. Seems like everybody had all sorts of thoughts about the squirrel gathering nuts, and I thought there's some really good interesting, fun sounding games there. Does anybody have any questions before we jump into the Unity stuff? Okay, I assume silence means no questions, so I'm going to open up that one we were doing the other day. And I'll just start there. That way we don't have to start completely from scratch with it. Because this will be kind of a common situation. Oh, that's not the one from the other day. Cancel. Oh. I think I missed the cancel button. Sorry, be just a slight delay as I open the correct one. I should really name these better. Okay, so here's where we were the other day. Instead of using our normal WASD keys to move around, we just kind of point at the spot we want to go, and an internal AI figures out what the best path to get there is. From the spot we previously were. So nice easy way to move around. We use what's called Navmesh agents. Pathfinding is the generalized term for it. So in our player object, we included this. In our player object, we included this Navmesh agent, and then in the script, we just access that. Well, we set up our world. Every item in our scene has to be set to either movable or static. Static means it's part of the world, it can't move. So everything we want to walk on or around and all of that, we have to set as static. And then the thing I couldn't remember is I was looking for I was expecting a preview the other day, which there is no preview on it. But when our settings are ready, like how high up can the player step, or what angle of an incline can they go up, and a lot of settings, then we bake all those settings in, and then we can see our walkable area versus the not walkable area. And we can do more. We can set up multiple things. there's lots of different types of areas. We can customize areas. We can set up more than one agent. So we could have something that walks on maybe something that can walk up really steep things, step really high. And we bake that, we get a different one, different options. Oh, I think I meant to change these. Get different options than where our player could walk. So we can set up different things. But typically in a game, that's going to match between our player and the opponents, right? If we have a human-shaped player, it's usually going against human-shaped opponents, which means they have the same restrictions for walking and stuff. So we can use that same nav mesh for more than one. We can set up more than one mesh or define different areas and have some for the player and some for the opponents and things like that. But in general, there's that alignment between the general shape of our main player and the opponents they're going against. So we can use the same nav mesh for more than one object. So I'll do that and create our character. Something like our characters. Oh, yeah. I think I have to click that again. For some reason, Unity won't actually open Atom for me. It'll open files in Atom as long as it's already open. And then as far as script goes, it's really easy. We just created an instance of that data type. And in order to find where, then the get component. And in order to find that, we used ray casting, which is kind of like a laser pointer. We shine a laser pointer somewhere in the game and it's just a line that continues forever until it hits something. And the easiest way to grab that is that's what our camera does all the time. The camera just shoots out rays in every across that entire field of view. And if it encounters something, it just brings back information that says there's something there. And talks about the material and the shading and all of that stuff. It explicitly describes what's there so that it can be rendered on the screen. But we can easily use one of those rays if we want something like a mouse click. So that's what we did for our player. We just randomly did a mouse click and then made that the spot we want to move to. Which, if there's not something in mind, we're just going to set that as our new goal, and then the computer finds the shortest route to it. So we can have since we're looking at this the other day, figured we'd just start here with our opponent movement as well. So I'm going to create some enemies. I'll create an empty, there's a filter on it. That's why I didn't see it. So rename this as opponent. Oops. We'll try that again. Rename this as opponent. And then an empty object to handle our logic and just some placeholder graphics for now. Our players are spheres, so maybe I'll make this a cylinder. That way the opponents look very different than the players. The things we want to do every time, we'll need to set that up to have a game object. So up and make sure it's in the parent object. We're going to add a collider. Don't see a cylinder collider on there. A capsule is kind of the closest fit to a cylinder. Oh, whoops. Let me undo a couple steps. So I want to keep that image at the same spot as the parent. Otherwise things will get confusing. So I'll come back over here. So I'll add a capsule collider. If you weren't familiar with it, whatever's selected in the hierarchy, if you put your mouse on the over in the view area and push F, it will focus in on the selected item. And our capsule is kind of just an elongated sphere, so we can stretch this out till it seems to cover the character. Look at different angles, make sure, whoops. Make sure it covers its whole body. That'll probably be good. Just enough to detect the collision. Then a rigid body, the things y'all have seen a few times by now. Rigid body gives us our laws of physics so that things can move with physics, and we can talk about movement tonight. So that can be that'll be a big deal before long, because we have two ways to access our position, either directly through the transform or through the rigid body. And I only want to freeze that. I don't want to freeze that position at all. I don't know why I was clicking that. I just don't want it spinning. We can access the transform directly, or we can access the transform through the rigid body. And that latter option is usually better, because then we're accessing it through the laws of physics. So when we start moving and come to a stop, if we're directly controlling the transform and just say move this many this distance each frame, it's just going to move that no matter what. But if we go through the rigid body and pass in that same instruction, it has to follow the laws of physics. So it has to, it has to accelerate up to its moving speed, and then at the end it has to decelerate. It can't do this like sudden stop, or if it runs into something, it bounces off. So if we're trying to get that touch of realism in there, we want to access the movement through the rigid body. That's included in our Navmesh agent. So I'll just run this, check the collider. Okay, so it looks like it roughly sits on the ground. I don't know what my character's doing there. It's just going somewhere strange. Our character kind of walks around still, pushes that out of the way because it's not a static item, it just runs into it. But we need that thing to move along with our character. So a good way to get it to move would be just follow those same movement patterns. I'm going to bring this up because unlike our character, that one did not sink into the ground. That looks like it's about the bottom. And the general rule from programming, you want to run a check every chance you get. Well, that's not working at all. I'm going to try a box collider. Y'all know the process in programming. Try something. If it doesn't work, you can try something else. Let's see if this sits flat on the ground. Or if maybe this would be better. Scale the Y. 0.5. There we go. Something closer to the same size as our thing. Then when we run it, does this appear to sit on the ground? That's close enough to the ground. Maybe a box collider would have been better for that sphere and prevent it from falling in the ground. Let's see if that works. What number is that? 0.5. Remove that, and let's see if a box collider looks a little bit, prevents that from falling in the ground, sinking in the ground. Nope, that didn't help either. I don't know why the sphere is doing that. I never did figure that out, but looks like it does about the same thing either way. So that gives us our rigid body and for the laws of physics and the bounds for it. And then to move around like our character, we need a NavMesh agent that can work with that stuff. So we have several types I just kept clicking new as I was talking about stuff. So we have multiple types of agents. We'll just use the humanoid one so that it moves in the same manner as our character. Some sort of speed, which you probably realize very quickly, we most likely when our opponent's moving a little slower than our character. So the character has a speed of 3, so maybe the opponent could move at a speed of 2. Might need to up that to 2.5 or something, but a little bit slower so that it's possible for it to catch up to our character, but our character can still get away from it if need be. The other ones are probably good for now. We're just covering the basic idea here in our short amount of time. But the Navmesh agent will allow us to move around that same way. But we have a little bit more to do, because for our character, just like for our player, we move around based off where the mouse click is. We'll want to avoid stuff like that. Try to find time to do in that. That's well, avoiding the opponent would probably be on the character. But when we just run, our opponent's not doing anything, so we need a script for it as well. So I add another script, a new script. I'll just make a new script called opponent. Whoops. And I'm gonna clear some of this stuff out of here. There we go. Get some of that other stuff out of the way. So we'll need basically the same things. We need our Navmesh agent, which is in this other library here. So using Unity engine.ai, run a Navmesh agent, just call it agent. And then when we start the game, it's just going to be our normal grab the component. The Zoom pictures are in my way. There we go. Navmesh agent. So that gets that. And we need our component to move occasionally, change direction, look at different places. So that part will be as straightforward. When we do that is going to be a little bit different. I'll show you the way I like to do that, because it did relate to a question that was asked recently about timers and stuff. Somebody had asked that about had a question about timing things, and I have a way to do it in game engines that at least makes more sense in my mind. That tutorials always seem to go back to a clock, and I think we have something a lot easier. But first off, we need to set up our change of direction. So I'll create a method to do that. Void change direction. Seems like a good name for it. And well, here we had to figure out where the mouse click was, and then once we had the point that mouse click was, we passed it in as a vector 3 and then use that. So that's the part we really need, is just that pass in that vector 3 point to set up our destination. Actually, I could do that more consistently, couldn't I? Oh, this will work. So whenever this change direction method gets called, we want to basically move in a different direction. We'll create a new vector 3 call that our new point, and needs to be a new vector 3, and we'll pass in some arguments for it. For the most part, our enemy is just going to be moving in random directions until it's ready to attack us, right? They're wandering around aimlessly looking for us. There's a couple things when we manually code in that we have to worry about that don't necessarily show up here. In particular, there's an edge to our world, right? So if we were just randomly picking directions and moving for a few seconds, there's a chance that enemy just might walk off the edge of the world, which is one of the really nice advantages of the nav mesh. Is that not baked in there? Or am I looking at the wrong thing? Okay, apparently I cleared it at some point. Unless I'm, yeah, still looking at the human one. Okay, so yeah, bake that back in. But here we don't have to worry about that because that's our walkable area. So our walkable area doesn't even go to the edge of the scene. So doing our enemies this way takes one of our big concerns out of there. Just the enemy going, doing something nonsensical. And then we can do the same thing. Once we have that point, we just do agent.setDestination to that point, and it will keep moving there. So agent.setDestination to that new point, and it will move there, and probably still just a random point. So it'll try to start moving in that direction. I think this has already shown up. If you go and like, okay, I need to do random numbers in Unity. So if you search random numbers in C#, you'll see these things. I'll click on the official documentation. You'll see all this. And then when you start putting that in Unity, you start to get weird error messages. That's because Unity has their own random thing. Unity has a random thing that's set up better to work better for games in specifically. So even though we're doing everything in C# script, when you go to look it up like that, make sure you check in Unity first. And then if you don't see a good example, then go in C# second, because they did customize their C# a little bit. And random numbers are one of those things. We have this thing. Let me just do a quick script. Well, that'll be fine. We'll see it here very shortly. We have this thing random.range. I'll just, since I'm back, random.range, which is our Unity thing. And that gives us a floating point number between two values. So good thing to check. A good way to check this is actually check what those are. So here's our character, and as y'all are well aware, we can see its position over here in the transform. So it's at 0, 0, and edge of the world is over here somewhere. Looks like about -9.3 or 9.15. If we go this way, looks like negative. Oh, I was looking at the wrong number. 8.86 down to -9.14. So I'm thinking a 10 by 10 would probably include both those directions. So usually it's really easy to check. So that's one of the the best ways to just kind of do that is move one of your characters around to see and actually grab the numbers from here, because our scales, as you do more and more things with Unity, you'll find out those, it takes a little while to set those up explicitly and to be some like meters or millimeters, or some of our graphics programs like Blender, we can set those sizes explicitly. And then when we bring them in, it just brings in the numbers and not the units, and we'll get funny things happening. Or if I click on the ground sprite, we set the scale to 2525, and then moving things around, we just saw the number for that is 1010. So the best way to find those things is actually grab one of your objects and move it around and check its transform. That's what I found is sort of the best way to find that. So our random range, we could go from -10 to +10. And I think this will work without throwing an error. Oh, well, if I get all the semicolons in there. This creates the 0 vector. If we don't pass anything, it's going to give us a vector 0, 0, 0. So that won't hurt to just look at an error message here. Did I leave off a 3? I did. We do have to say how many dimensions our vectors are, because vectors come in any number of dimensions. 2, 3, and 4 are obviously going to be the most common in games, but we might sometimes have other dimensions. So we do have to explicitly say how many dimensions our vectors are every time. Oh, I never called that method. Let me call that so we can watch that debug.log thing. I'll use invoke, because here's one way that we already saw we could slow it down. Change direction. After, I don't know, 1.2 seconds. That was just an easy number to type. But we can invoke that method after a certain amount of time. That's one way to wait for it. But I wanted to show you something that's kind of more generalized, that we will always have right at our disposal. So you can see we're getting random numbers. That might have been too quick. Somewhere between 10 and 10, and notice they're all integers. So if we turn those range values here into floating point numbers, we probably already know what's going to happen. I explicitly stated those are integers. So if we turn those into floating point numbers, you'll see now we get a floating point number in that range, which would probably be the one we're looking for. What happens if I go back to 0 here? Oh, 0 is too far down. 1, 1.2. That'll work. And again, check the numbers to make sure we're in about the right spot. Maybe 1.3. That way our collider is fully above the ground. Actually, we could go a little bit further and gravity will pull us back down. I forgot the laws of physics are. We do have the laws of physics applying, so if we come a little bit above the ground, it'll the gravity will pull us back down. And when you're trying to replicate realism, that actually helps with your animation, because if you pay attention to walking, we bounce a little when we walk, right? If anybody was in marching band at some point, that was one of the things that you had to actually learn how to do, was walk without bouncing, because otherwise it messes up playing the instrument. So when we lift up slightly above the ground and let gravity pull us back down, it gives characters a nice walk to a nice bounce to their walk, and helps with realism. Figured I'd share that since it popped up. Might as well do that here because it's not 0, so I'm not sure what the exact number should be. But a y of 1.5, and then we can do a random x and z and just have our character move in that direction. Have the nav mesh move our character in that direction. So, well, don't need to retype this, I already have it. So our x will be some random number. Our y, we want that explicitly 1.2, and then the same random number for our z direction. Will give us a point somewhere on our plane there, so that the character should start moving towards that after a couple seconds, which it happened quick. So I'm going to switch that around 2.3. Make that a little bit longer before it calls that. So kind of moving in random directions. Maybe not quite the one we're looking for. Kind of wiggling around. I think that's because it can't find a way to get to that y coordinate. So it prevents it from totally stopping. Might need to be a little bit longer than that. That's just changing the timing function. But starts to get us some movement there. Whoops, that's not the one I wanted. In general, I have a way that I like to do this in games. And that's because every game that we're working with, one of the key aspects is there's multiple frames going, right? We define what's happening frame after frame after frame. And we can go over to the project settings, and somewhere on here, oh, that's not the one I was looking for. We see different frame rates. So 60 frames per second, sort of the default, and slow it down. Do the normal television thing, because I don't know if you ever ran 60 frames per second on a television rather than a computer monitor. It looks a little bit funny, right? That's why there's a noticeable difference, right? So television, we can set it to television rate if we know it's going to be ran there, or define our own speed. But there's the frames pass over and over and over again. I'm going to go back to the default of 60 and just leave that like it was. So that's under project settings. So that's something we always have going. So whenever I'm timing things on a game, I like to use that. Things like invoke, that uses a specific clock time, right? 2.3 seconds. Or if we use time.delta time, that's a very common one. Time.delta time is the time of the frame rate. So that's in milliseconds. So 1000 divided by 60 is 16. Is that right? Whatever that number is, 16.7, repeating thing. Yeah. So that gives us the time interval between it. But when I'm putting games together, I find that a little distant from the way I'm thinking about everything else. Because everything else in the code, I'm thinking about frame by frame. So what I like to do is just keep a frame counter and just use that. So we have our main camera, so we could just use that for our, that's something that will always be around. So we always have that counter. I'll just put it right here in the opponent. Usually I would do something like that, put it in the main controller object, but this one's not going to get very big. So I'll just put it here in our opponent script. Let's call it int, and I'll call it frame, which starts at 0. And keeping the counter going is easy, right? At the end of every frame, we just say frame plus plus. It goes up by 1. And then when we need to do something, we can base it off how many frames it's been, rather than having to stop and think about how much time we want to pass. Just use frames. And what I usually do is I just keep that counter running forever, because when it hits the overflow, when it hits overflow of a 64-bit integer, 64-bit or 30, when it hits overflow on a 32-bit integer, it's going to come back to an overflow error, which a full overflow error will go negative. This one has some handling, so it'll go back to 0. But either way, even if it's a full overflow error, we'd get the same thing if we did the modulus operator on it. So if it kept going and it's like our sequence, we loop back around to negative numbers and they go in order. So if we were doing things mod 4, that overflow error wouldn't affect the mod 4 result. It's just going to keep going and going and going. So overflow errors aren't always a problem, especially if we break them down mod 4. So that's how I usually handle it. So instead of calling invoke, I'll just check that frame. So like if the frame or the number of frames that have passed mod something, let's see, 60 frames in a second. He's moving 3 every frame, which seems to cover stuff, and just kind of roughly break out the calculation or to match this. Maybe I'm going to go 2 seconds. We just do mod 120. So every 120 frames, if that is equal to 0, then we can call that change direction. That's how I usually like to do it. I set up a counter with the frames, and I just find it more intuitive, because whenever I try to go to because everything else in the code is frame by frame. So when we're diving in, focusing on writing code and in that mindset, I just find it a lot easier to keep thinking about frames and just time things that way. Just do mod something, and then we can do lots of them, right? If it's not modulus by 120, if that doesn't work out, what does frame mod 73 for some other thing give us? And then we can do a whole lot of counters off, just a whole lot of different actions off that one integer that just rolls on and on. That's just something I've found over the years that seems to make the code flow a lot smoother, because I always have to break my frame of mind from coding mindset and start thinking about real world time, like the time on the player's watch, which is completely different from the frame by frame coding. And then after breaking the mindset, I come back and I'm in the wrong mindset for coding the game. You see our enemy is just randomly moving around that way. Okay, 120 might still be a little short, so just try some numbers. So 300, that way he'll go for a ways. Let's see how far he walks this way. Big random number, kind of go around. And just find a number where it looks like he's ready to cover the whole, we'll cover the whole board eventually. Looks like he's going a good distance. We could probably go up a little, and I don't know, 360 sounds like a good number to pick. 365, and a year's worth of frames or something. And do the arbitrary trial until it seems like you have a good coverage. the normal guess and check that we often do with sizing. That looks like the character's moving around pretty good. Gets our opponent moving around, but there's one other thing we want to do. Like right there. Right? If he was moving around looking for our player, definitely should have seen him there. So we might want some of that going on as well. Which adding that part in seems like this might make a good break point before, because it's a little short of the time that I would normally think about a break, but that's going to take a minute to talk about, right? So as we move from that part into actually making the opponent look for our player when it's appropriate, seems like a good break point. So maybe a good time to take 10 minutes. Does that sound good to everybody or anybody? Okay, I see in the chat room. So it's 6:56. So we'll get back to it at 7:06, and then we'll add another thing so that it's not always random movement. Sometimes we want random movement, then we want it to stop moving randomly and chase our character down. So we'll see that after a short break. So I'll see y'all in just a moment.